Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super. Today, we're going to cast our minds back to the 6th of July. We're going to be focusing on an incident involving Azure Monitor, Log Analytics, and Microsoft Sentinels. And here today to discuss this with us, it gives me great pleasure to introduce Buck Hodges, our Partner Director Engineering Manager, and Jay Sauls, our Partner Software Engineering Manager. Both of them joined us from the Azure Monitor and the Platform Observability team. Gentlemen, thank you very much for joining us.
Great to be here. Buck, I wonder if you can kick us off, but before we get to the incident on 6th of July, could you just help us understand at a high level Azure Monitor, Log Analytics, some of the dependencies, and how we think of the monitoring suite?
Sure. So Azure Monitor is really more of an umbrella, a brand. So it encompasses a number of tools. So that includes Azure Log Analytics, which is, as the name suggests, really the place to go collect all your logs. And that also, and by the way, is built on top of Azure Data Explorer. So those of you who've used ADX or know anything about it or use the Kusto query language, you're familiar with the immense power it gives you to do a great amount of log analysis. So then Microsoft Sentinel, which Sami mentioned in the intro, is not part of Azure Monitor, but is an important part of what we'll discuss today. And Sentinel is actually built on top of Azure Log Analytics, where Azure Log Analytics is really the platform for Microsoft Sentinel. So going back to Azure Monitor, so we covered Azure Log Analytics. There's also Application Insights, which is really the primary tool for application performance management, or APM, as it's often called. They're also, those are the two biggest products that are within the Azure Monitor umbrella. You've also got Container Insights and VM Insights, where you're really going to get very specific information about certain Azure resources. Obviously, in this case, is big containers and virtual machines. So there are other pieces to it, but those are the main pieces and certainly most relevant to the conversation we'll have today.
Super. And before we get into all the details about what happened on the 6th of July, when customers are thinking about, we've got container apps, Azure Monitor, Log Analytics, Microsoft Sentinels, how do customers need to think about the architecture? How does data move from one service to another? Are they all intra-connected? Can you tell us a little bit more about the inter or intra-dependencies between those services?
I think Jay,
you want to take that, Buck, or you want that one? Sure, I can.
You can take that, Jay.
Go
ahead.
So Log Analytics is the core product in that suite for gathering and collecting the data and getting it to the right place. So the general pipeline that exists has an ingestion gateway that accepts the data from all the different agents that are out there. And there are actually several different flavors over time of those ingestion gateways as we've gone through different iterations of the agents that we provide. But ultimately, most of that data ends up going through a core ingestion gateway, either directly or indirectly, and then getting written into some storage accounts that we have managed internally. And then from there, the data gets sent to wherever it needs to go. And in the case of Log Analytics, that's almost always either a shared or a dedicated ADX instance where the data is then written.
Got it. So I think now that we understand those different moving pieces, let's focus on the issue itself or the incident. So Jay, we mentioned in the post-incident review that there was a problematic deployment, but it wasn't actually a deployment on the monitor side. Could you help us to understand kind of what happened?
Sure, that's actually very correct. So in the case of the incident that occurred, the ingestion gateway that I discussed earlier ended up having a problem because of the control plane that it depends on in order to get access to the storage accounts where it ingests data. And what happened was that control plane got overwhelmed with traffic. And that was really interesting from our perspective, how that happened. We were working on a new agent to collect data that we were running internally that's based on OpenTelemetry. And in the implementation of that agent, its interaction with the control plane accidentally ended up using an API that it shouldn't have used. We basically have two sets of APIs that we present for the internal control plane for the telemetry at Microsoft. One of those APIs is designed for the 25, 35 million agent instances that we have running, monitoring all the internal Microsoft services throughout the whole company, not just Azure, but also Office and Xbox and everything. And those APIs are set up to be very, very highly scalable. They have throttling, they have extensive caching, positive caching, negative caching, all that fun stuff. There's another set of APIs that we use for management, deploying new configurations, updating those configurations. And those APIs are set up in a way that you can read what you write. And what that means is if you make a configuration change, you want to be able to read that immediately to make sure that the configuration change took place and have consistency in the operations that you're doing. So the management control plane APIs are not cached, they're not throttled. They are set up in such a way that they're intended to be used only for control plane operations. And so what happened was the new agent implementation that we were working on accidentally chose to use the wrong API in one case. And so instead of reading from the cached API, where they would be getting their configuration information, they were actually reading from the control plane API. And internally, one of the teams that was piloting this rolled it out using safe deployment to the stage regions, and we're monitoring it. And they discovered that for reasons completely unrelated to that agent, they had made a misconfiguration on their service. And that misconfiguration in their bootstrapper caused the bootstrapper to start and then abandon the start and then restart. And that was doing that in a loop every 3 to 5 seconds. One of the only things that it managed to do before it exited and started the loop again was it managed to start an instance of this new agent. And the only thing that new agent managed to do before it was killed because of the restart of the bootstrapper was that it went and called this expensive API to go get its configuration. So we ultimately ended up kind of with an internal denial of service attack against ourselves, where we had an agent that was basically hammering us with requests, and those requests weren't cached. They were going directly down to a storage account to retrieve the configuration information. And we got to a state where that storage account basically ran out of throughput. It didn't have any IOPS left to be able to serve other requests. And that caused a cascading set of effects that we can talk about here in just a minute.
Super, thank you very much for that. It's interesting because you talk about the deployment of another service and so on. I know we don't have a culture of finger pointing, and Microsoft's always kind of in this to learn from each other, and we operate as one Azure. But who's accountable for what deployments between what teams? How do the different teams, when you take a dependency on another service and they're making deployments, how does that interoperability between different teams across the platform?
Well, it's somewhat similar to the way that we provide services to our third-party customers, in that we publish a set of APIs or a set of tools, and we expect people within the company to use them, and we expect to be resilient to their use of the system. And in this case, the correct set of APIs would have been resilient to this case. If they had started hammering us with a whole bunch of requests, we would have noticed, hey, there's a whole bunch of requests coming in, but they would have been filled very quickly, and it wouldn't have been a big deal. But in this case, we were the team that was working on the agent was working closely with 2 or 3 internal partners within the company to pilot the agent, and the team that was rolling this out was one of them. They were doing exactly what we would expect them to do. They were doing a safe deployment. They were rolling out region by region. They were observing whether or not they were having issues. They noticed by the time they got to, I don't know exactly how far it got, maybe 2 regions of the stage regions, they noticed that their bootstrapper was not working correctly, and they stopped their deployment. The challenge for us was that was enough instances of the agent deployed calling this incorrect API that it was causing us issues.
That's really helpful to understand. So that they were calling the wrong API initially, and even though they caught it early and stopped the deployment, just those initial ones were enough to kind of throw us off kilter here. So I'm interested, I'm not sure, maybe this is a question for you, Buck, when the service was initially getting hammered by that new volume coming into the API, why didn't we detect those issues earlier? I was looking at this issue, it seems like this was actually quite an extended impact. We noticed that we were getting hammered, we weren't sure where it was coming from. Could you help us to understand a bit more about how we detected and ultimately investigated where that was coming from?
Yeah, it was a really subtle issue, and Jay can go more into the details of exactly how it manifested. But we had some early indications that something wasn't quite right, but it didn't look that harmful. And so, it's one of the interesting challenges, right, to make sure you have the right signals coming out of your system. And one of the things that we're changing as a result of this is improving those so that, should anything remotely like this happen again, will be very clearly alerted beforehand. Jay, do you want to talk some more about the actual details around the detection?
Yeah, one of the first places we noticed this is that we have a internal system that's very much like the RM deployment system, where customers our customers internally, the first party teams, are changing their configuration for their telemetry, and they're deploying it via a mechanism that looks very much like an RM deployment, where you have a template and you deploy it. So that system, we have a resource provider for it, and it's constantly getting changes and updates from teams as they're trying to figure out their deployments. And a typical pattern is that you make a change, you do a deployment, it has an error. You make a change, you do a deployment, it has an error, and you kind of iterate your way through it until you get it right, and then you deploy it and it works. Well, that API started throwing errors, and we looked at it and we're like, well, yeah, this API always throws errors because there's always customers who are deploying stuff that doesn't work, and then they retry and then they work it out. But we saw that rate of errors spike up, and we didn't understand why. And so that was one of the earliest signals that we had that something was going wrong. And unfortunately, we didn't really dig into that to understand it fast enough to be able to pull on the threads and realize that other things were going on. But basically what was happening was the storage account where we store this information, this configuration data, started throttling. And that throttling was causing intermittent failures, very sporadic at first, but then it started getting more and more intense. And it took a while before the throttling rate got high enough that we really understood, okay, something has changed in the system. This is not just a transient spike. And we had to go dig in and figure out what was going on. But it took us a while to understand that this was something abnormal, in the sense that, occasionally storage will throttle us and then it subsides and goes away. This was a case where storage was throttling us and it wasn't stopping. And that's what took us some time to figure out that it wasn't gonna self-mitigate.
When I was reading the PIR, it sounded like initially we started kind of offboarding services or stopping services from calling that API. What are the other steps that we took to mitigate here? I understand we published things, but just kind of behind the scenes so our customers understand it. What went on with the teams on troubleshooting and narrowing these things down?
Yeah, so once we realized that we had a non-transient problem, we started doing several things simultaneously. So one thing that we did was we have some ancillary services that run internally that do things like delete old data, we have something that we call node diagnostics that allows us to reach out to nodes within the Azure framework, or the Azure system, and retrieve information off of them. These services are not critical to the operation of day-to-day stuff, but they do put load on our operations store. And so we just basically immediately started shutting those off. And so that started relieving the pressure on the operations store. And simultaneously, we started trying to track down, okay, what has changed in the API calls and the API signatures that we're seeing. And we identified that something had started hammering this operations API that I talked about, this management API that I talked about earlier. So while we were pulling on that thread, we eventually got to the point where we realized that there was these set of machines that were calling us very, very calling this API way, way, way more frequently than we would expect, 100 times more load than we would expect. We would expect somebody to call this API once a day, once every 2 days, something like that. But instead, there were thousands of machines calling it every 3 seconds. And so once we identified that set of traffic, we started deploying IP blocks to basically eliminate that call from even hitting our front end to begin with. And then we also started trying to track down the team internally to figure out who they were and understand what had happened. Because at that point, we didn't, I'm telling the story backwards with hindsight, understanding what happened. But of course, as you go forward in time, you don't necessarily have the ability to put all these pieces together and understand the whole picture. So anyway, we took off the load, we took off the extra load for things that weren't immediately critical. And we went and we blocked the requests coming in from this service that we didn't understand what it was at the time. And then we started trying to track down that team and get them on the phone and talk to us about, hey, what have you guys been doing? What's going on? And so all of those things were going on simultaneously. So that started at about 7 o'clock in the morning Pacific time, 7:30 maybe. And then by about 2 o'clock, we thought we were in good shape. We had blocked the traffic that was coming in. We had taken off a bunch of load from the operations store, and we were watching our indicators start to return to normal in terms of load on the storage account and API call rates and things like that. But unfortunately, that return to normal didn't happen fast enough. And so what started happening was the ingestion gateway, which is also calling the same control plane service in order to get its security tokens to go talk to storage, it started getting to the point where the security tokens that it had started expiring because they have a limited duration of time that they're good for. And it started getting failures from the control plane when it went and tried to renew those tokens. And those failures were basically because there were too many outstanding requests from all the noise that had happened earlier against the control plane in order to be able to satisfy those calls. And so even though we had basically eliminated the source of the bad traffic and we had taken the load off of the machine, taken the load off the control plane, the ingestion gateway was still getting failures trying to retrieve the storage tokens. And then it got to a point by about, I don't remember the exact time, 6:30 or so in the evening Pacific time, where it started having to reject traffic that was coming in because it couldn't write the traffic to storage because it didn't have the updated security tokens. And from that point, that's when the external impact started happening, and teams got into a state where they couldn't upload their telemetry data from their log analytics agents, and that's where we really started having the external impact.
Got it. That's a great rundown of kind of, like you say, piecing together during the fog of war, how we figured it out, what initial levers we could pull, and ultimately kind of how it was mitigated. I'm interested if we could pivot to our repair items now that we've kind of looked back on this incident and we understand a bit more about what happened. In the post-incident review, there's a question that says, what are we doing to make this less likely or less impactful? And I wondered if we could talk to each of those. What are we doing to make this kind of thing less likely? And then assuming that we don't get that risk down to zero, what are the types of things that we can implement to make sure that even if something does go wrong, that it would be ultimately less impactful? Jay or Buck, who do you think?
I can take a lot of those. Buck will remind me of the ones that I'm not remembering. So one of the important things was this management API that we expect to have very, very low call rates. We're actually going to enforce that. We're putting very strict throttling rates on there. And so, it's something on the order of like 1 call per minute is allowed or something like that. So if anybody abuses this accidentally in the future, they're going to come complaining to us almost immediately saying, why am I constantly getting throttled? Well, you're getting throttled because you're not supposed to call it that much. So that's in place very shortly. We've been working on that. We've added additional alerts in several places. For example, the throttling on the storage account that we were talking about earlier, where we store all this metadata. We're getting those alerts directly from we're getting the metric directly from the storage account now, and we have high severity alerts defined on that. So anytime that account starts throttling us, we're going to know about it immediately with something that's going to wake us up in the middle of the night to go investigate, because that shouldn't be happening. And if it does happen, we need to go investigate right now. Another thing that we're going to do is something I didn't make clear earlier is we have an ingestion gateway for log analytics dedicated, and we also have ingestion gateways that we use internally for the telemetry system at Microsoft. The control plane that I've been talking about actually serves both of these needs. It serves the internal one for Microsoft, which ingests about 600 petabytes a day of data, and then it serves for the log analytics ingestion gateway as well. What we're going to do is we're going to clone that service, and we're going to dedicate one instance of that control plane strictly for the log analytics ingestion service, so that there's no internal traffic coming to hit that control plane. It'll be strictly for log analytics, and that'll create some isolation for us and prevent. This particular kind of issue would not have happened if we had that, but it'll also just decrease the risk of something like that happening in the future, because there won't be random things popping up all the time. Like, inside Microsoft, a new service comes up, it needs telemetry. they're going to add, their agents, and that's constantly changing over time. When we dedicate this control plane to log analytics will be the only thing using it. And so we'll have, very strict change control on that and say, okay, well, we know exactly what's using it and we know how that changes over time.
So Buck, before I move on, is there anything there that Jay's missed that we should be touching on?
No, he did a good job summarizing it. There are some other sort of lesser things like extending the token lifetimes, which will give us more time if something goes wrong, give us more time to fix it before it has customer impact. So, our whole goal with this is A, make sure we know if there's a problem, B, like in the case of throttling, prevent the problem wherever possible, and C, make sure that if there is a problem, that we give ourselves the most time possible to deal with it. And so, making changes to the token lifetimes, for example, really buys us extra time to make sure that, we can get the thing fixed before it has customer impact. So, we've gone through these. We've got a roadmap for short-term changes and medium-term changes here over the next, several months, and then some longer-term changes that we're considering that are bigger. So, yeah, this was a big event. Anytime you have data loss, it's a terrible thing. Like, it's one of the worst things you can possibly do as a service. And so we turned over every stone, looking at everything we could do here, not only to fix it permanently, but really the short-term mitigations to minimize any chances of this happening again in the short term while we make the longer-term architectural changes that need to happen.
The architectural changes are really interesting, particularly around creating that replica that serves the internal and the external and splitting them out. I have a small question. I mean, it might seem silly. In my years of reading PIRs and understanding what service teams are going to do, of course, we're familiar with things like throttling and caching. I've never heard of positive and negative caching until I kind of stumbled across this incident. Could you explain for, well, I say our customers, but also me, the difference between positive and negative caching and how it's used?
Sure. Yes, I don't know if it's a standard term, but we use it internally. But the idea is positive caching. I'll use the example of the configuration that we use for our monitoring agents. The monitoring agents start up and they say, "Hi, I'm part of this workspace or I'm part of this namespace. I need my configuration," which is generally a JSON or an XML file that we download to the agent so that it knows what to do, what to gather, where to send that data, all that fun stuff. So positive caching would be the front end basically goes to the underlying op store, grabs a copy of that configuration, and then stores it in a local cache, whether that's in memory or Redis or whatever. But if an agent starts up and it's misconfigured or it's asking for something that doesn't exist, we refer to we will go and check the first time the agent asks for it. We'll go and check, hey, do I have a config that has this name? And if that comes back as no, it doesn't exist, we'll cache the fact that it doesn't exist. And so we call that a negative cache. And so if there's a whole fleet of agents that start up at the same time that are associated with the service, and suddenly there are 10,000 instances of agents that are all asking us for this thing that doesn't exist, we cache the fact that it doesn't exist, and we remember that for some appropriate amount of time, 15 minutes, an hour, or whatever. And during that period of time, we won't go back and ask the underlying operations store, hey, does this exist? We're just not going to go. We're not going to go look for it. We refer to that pattern as a negative cache.
That's good to know. Thank you, Sammy. I didn't ask it myself, but I wondered. The last question that I have for Buck and Jay here is, we always try to make sure that these conversations include a section on customer resilience. We like to show, this is how some customers weathered the storm better than others. I take it because of the global nature that this wasn't something, oh, well, you expected to have a backup in another region. That doesn't help here. But I do understand some customers fared better or worse based on which monitor agent they were using. Buck, is that right? Or what else could customers have done to try to protect or lessen the impact here?
That's right. So there are multiple agents, as Jay mentioned, that have been released over time that are used with Azure Monitor. One of the sort of the older agents is Microsoft Monitoring Agent, and then there's also Azure Monitor Agent, or AMA. So you got MMA, Microsoft Monitoring Agent, AMA, Azure Monitor Agent. So these two agents have very different approaches to buffering and retries. And what we saw was we had a large customer using MMA, and the retries and the buffering there are far less robust than with AMA. and in their case, they suffered significant data loss. We had another very large customer who is almost entirely on AMA, and they suffered very little. Now, during the incident, both were equally blind. They were not getting their telemetry. But once the incident had been mitigated, customers using AMA fared much better, as most, if not all, I'm hesitant to say all, but the vast majority of the data was buffered and was sent up and ingested properly post-incident. So I would strongly encourage people to go look at and adopt Azure Monitor Agent if they're able to do so. The challenge, and the reason there's an asterisk there, is that Microsoft Monitoring Agent includes what are called solutions or plugins, and not every single one of those is available now for AMA, which is in fact what is preventing AMA being the fully GA solution that replaces MMA, because MMA is on a path to deprecation. So if a customer doesn't need those couple of solutions or plugins that are only available for MMA, I highly recommend people move over to AMA, because it will make them much more resilient to this type of incident, or really any incident, which could include, for example, network connectivity problems. I mean, all sorts of things that obviously can go wrong. So that would be my biggest recommendation to people.
Got it. That's helpful guidance. And then, Sammy, I'll turn the tables on you, since you run the Azure Communications team. How did our comms go during this incident? Were we able to keep customers informed? I saw some folks commented on getting duplicate notifications. How did we do? Where can we improve from a communications perspective?
Yeah, there's three things to call out here from a comms perspective. The first one is we have service health alerts, which we send communications directly to impacted customers and their subscriptions. Now, these are based off Azure Monitor. Now, Azure Monitor was impacted, but this portion of Azure Monitor, which is responsible for sending service health alerts, lives on what we call dial tone infrastructure. And this means that even when Azure Monitor is suffering or bleeding, or if it was completely down, those service health alerts would continue to go through to let customers know that there's an issue. So, I mean, it's an interesting piece to note about the Azure Monitor service and how Azure Service Health leverages it. The second piece is, you're absolutely right. If a customer has 100 subscriptions, we would have sent them a notification, and that could have resulted in 100 notifications if they set up an alert for each subscription. We know that aggregation is a problem. We know it can be noisy, and we are working on it. It's a non-trivial issue to solve. When we think about the different services and regions and what experience that would look like, it becomes very complicated as you scale out, and as different customers using different services in different regions, what those alerts look like. So it is something that we're invested in solving. We're making progress, but it's a non-trivial thing to solve. The other one that's interesting is, I think we need to make a pivot, because today every customer has access to Azure Monitor. All customers around the world, have access to Azure Monitor. It's not a service that you deploy like you would a VM or anything like this. But I think we need to be more refined, because not everybody uses Azure Monitor in the same way. And I think one of the motions we're going to go towards is to say, if customers have set up alerts, or they've set up some sort of rule or a trigger, then we can notify them. Otherwise, many customers who don't typically use Azure Monitor in day-to-day, they would have received these notifications. It's noisy for customers. We don't want to create noise. We want to be very relevant to say, hey, we have something to tell you, and it should be pertinent. So there is some improvement areas that we need to do in the communication space, but those three things were really top of mind as we look back on the communications throughout this incident.
Great. It's good to hear that just as our service teams have some learnings and improvements, as does our communications team. So thank you, Sammy, and thank you to Buck and Jay for joining us, and thank you to everyone dialing in, watching this Azure Incident Retrospective.
Super, and we keep thinking about outages are inevitable, and particularly at the scale in which we operate. The idea is that we're not going to eliminate outages. We know that they're going to be impactful events that are coming on, but this is really to ensure that the cloud, or when there is an incident, an outage, it's not a black box. It's not a mystery. We want to bring you closer to our SMEs and our leaders so we can have the conversation and shed some light on what's happening.
Great, and just as we've got plenty of learnings and improvements we've run through, we also want to make sure our customers and partners can learn from these incidents as well. Buck talked a little bit about some of the agents to recommend. We've also got the Azure Well-Architected Framework, which has an entire pillar on reliability guidance and how to make your workloads more secure.
And the same way that we communicate to impacted customers about events, and we'll send impacted customers a post-incident review. In this one, it was published to status.azure.com. But for customers who want to get invited to these events to learn more about what happened and to be able to ask our SMEs questions directly, customers should be setting up Azure Service Health alerts on our dial tone monitor, Azure Monitor infrastructure.
Great. The whole reason we do these sessions, we know that trust needs to be earned, needs to be maintained. We really want to focus on showing up, being accountable, being as transparent as possible after major incidents like this one. So thanks again for joining us. We hope you found the conversation interesting. Have a great day. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get post-incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us. Thanks.